we're going to recognize our friend, classmate, Aaron. Have a birthday shout. Hooray! Hooray. We're here to sing to you today. 1 year older and wiser. Happy birthday to you. Happy birthday. Yay. All right. And also, we're going to be resuming our class from yesterday, our problem that didn't really work out too well. And the reason is, I will show you the reason it didn't work out too well. As we put this in the calculator, and you have your calculator, Gavin? That doesn't look like the right calculator right there.
Not like
So anyway, we got quantity x plus 2 to the fifth, which is quantity x minus 3 to the fourth. Quantity x plus 2 to the fifth. Fifth times quantity x minus 3 to the fourth. And basically, the critical numbers we had on that were good as far as it went. But then we graph and we see, yes, -2 and 3 definitely are critical numbers, but we missed one because the function to connect, and we're not talking about a vertical asymptote here either, is going to be way up here. What I did yesterday after class was I looked at what this whole graph was. I didn't quite get the top. Let me go ahead and adjust that window a little farther. Is it 4,000? I'll make it 4,500. That should get the top. Yeah, there we go. And so here, there is a critical number that is missed. And so,
3, not 2.
yes, it would be 3 critical numbers. And this is definitely, we see the -2 and the 3, that looks good. And we can see that this is like not a change. So that's a critical number, but not a minimum or a maximum. So let's go ahead and continue working this out, because we know graphically that 2 has been contradicted. So let's continue here. So what we have to do is take this and continue working. And this is just an example of kind of being at the end of class and being a little lazy. And so, was I a little lazy yesterday? Yeah, but I had reason for it. So let's go ahead and continue to work this out and see if we get something. Now, what's going to be our common factors of these two things? We're talking about this thing here on the left and this thing to the right of the plus sign. Yeah, so which power do we use? It's going to be x plus 3 to what? X minus 3 to what power is our common thing between these two? The lowest one. 3, right? And then what's going to be between this x plus 2, what's going to be our common to the fourth, right? So now we've factored out these two things, and then we pick up what we have left. Well, what we have left out of this is we have a 4, right? And then what do we have left here? We have 1x plus 2, right? And then we have plus, and we factored out this we have this x plus 2 to the 4th power and x minus 3 to the 3rd power. Well, that's factored out. What do we have left here? We're going to have 5
1x minus
x minus 3, right? And so now what we have to do is simplify all this right here, and we should get our other critical number in that manner. So I'm just going to rewrite this x minus 3 cubed, x plus 2 to the 4th, and then we have this 4x plus 8, and then we have plus 5x minus 15. And so we have this thing right here that we can set equal to 0, find our critical number. So we get, adding together, we get 9x minus 7 equals 0. So x is equal to 7/9. And so that's going to be our other critical number. Let's go check in the calculator to make sure that's what it is. We're talking about this one up here, right? So we go to second, trace, and we go for a maximum, and it says left bound, press enter, and we go over to the right here, press enter twice, and here we have it. Does that look like 7/9?
Oh, yeah.
Yeah, that's going to be 7/9. Okay, so that's where it is, so that's worked out. Okay, let's go on to the next multiple choice problem here. The derivative of this function here attains its maximum value at x equals question mark. I want you to do that one. I think that's 4th and 5th, is that right?
Mm-hmm. A full. No.
That's 4th and is that 5th? Does it look like that on your paper?
Yeah, I think so.
Okay.
Pretty small.
I don't know if that was take the derivative of that. Here, I'll still do some. So we get So anyway, here we have we want to find the derivative attains its maximum value at x equals. And so to me, what you have to do is you have to take that second derivative and use it to find the maximum value, to find a relative maximum. So if we go ahead and take a second derivative, what do we get out of this? Well, we're going to get 3 over 3, and then times 4, x squared, and then we're going to have minus 4x cubed. Does that look right? And they'll cancel out. So if we set that equal to 0, we get our common factor between these two looks like 4x squared. Does that look right?
Yeah, that's what I...
4x squared, and then we have 1 minus x. And so you have x equals 0, and x equals, what is that going to be? 1, right? 1 minus x equals 0. That's x equals 1, isn't it?
Yeah.
And then, what is that going to look like? Here's our critical numbers, 0, 1. Here we have, now remember we're trying to find the maximum of this. So what it is, it's like here's our f double prime, and we're looking if f prime is increasing. So we do our analysis based on that. And so to the left of this, if we plug in a number less than 0, we're going to have positive times positive, so increasing. And then to the right of 0, we're still going to have, between 0 and 1, we're still going to have positive, positive. So that is not it. And so it's going to be this, isn't it?
Mm-hmm.
So it's going to be minus, it's going to be at x equals 1. That's where that's going to be. Okay, so taking two derivatives, drawing a quick number line. Is that what you got for that? Yeah.
Indeed.
Now, Gavin, that's not that hard, is it, Gavin?
Wasn't too bad.
No, it's too bad.
Took me a second to look at it and realize what it's...
Yeah, and this is an interesting problem, or a strain, whatever you want to call it, because and they did italicize this to sort of, that's the only warning they gave you, because usually you'd say this, you're looking for the maximum value of this, and if you actually just found the maximum value of this and didn't take the second derivative, you would have got one of these other answers, and that was the distractor.
It's
So,
tricky.
yeah, so this is a tricky one because of that. Okay, next, let's go to this last. And these last two ones here, this one and the last one, were ones that are going to, they'll take you a couple minutes at least to solve those in an AP test. Okay, next one, you have if f double prime equals x times x plus 1 times quantity x minus 2 squared, then the graph of f has inflection points when x equals, and if you pay attention to multiplicities, this is a 10-second question.
Well, I have an answer, and I think...
What is your answer?
I'm afraid to tell you because I might be wrong. I chose E.
You chose E? Well, the right answer is C.
Oh, because the freaking... I did it too fast yesterday.
Yeah.
I know why.
Why is that?
Well, I know why it's for sure negative 1 and 0, because whenever you want to do the...
Yeah, it'll
Swap
change.
those out. But then because of the freaking square thing up there.
Yeah, and what it is that you're not changing this even number multiplicity does not change concavity, but these do.
Yeah.
And so if you write out, and of course, you write out a number line, your critical numbers are going to be 2 and negative 1 and 0. And then you work it out, you have f double prime and f down here. Well, to the left, you'll have, this is always going to be positive, right?
Yeah.
And to the left of this, you're going to have a negative times a negative, which is going to be positive. So you're going to be going like this. And then between negative 1 and 0, you're going to change here. That'll still be negative, but this will be positive. You have a negative times a positive. So there's one inflection point. And then when you have greater than 0, you have a positive times positive times positive. And so
So it stays positive.
So it stays positive. So your only inflection points are going to be at x equals -1 and x equals 0.
I did in my head and I didn't see that it was squared.
So you didn't notice that? Yeah. Just something to notice. And this is one that if you really understand what is going on, this is a 10-second problem. If you don't understand as well what is going on and you need to write out the number line, this will be over. This will be like a minute or two.
Easy peasy.
Yeah, so so some good problems there from actual AP tests. All right, what I want to do is go to some of these here. I want to draw some sketches. And I'll tell you, we're not going to do all of these. Okay, what I do is I want you to go to this one right here. You see where it says example 2?
Yes.
This see where that is, Gavin?
It's a few pages away.
This here?
It's on page 8 on.
Page what?
It's on page 89.
Now, what happened the other day, remember a couple days ago we did the matches of F. So what we're going to do is do some possible matching graphs, and it's going to be hard. So here, what you're given a graph of f prime of x. This is f prime of x. Then it's asking what is your possible f of x.
Oh.
So here's your derivative on the left side. Okay, what is going to be the antiderivative of that? So if we have this on the first one here, we have a horizontal line. Looks like y equals 2. So what is going to be if you have f prime of x is equal to 2, what is f of x going to be? What is f of x going to be? Question mark.
Wouldn't it just have a straight line?
Yeah, so what kind of line? What does that line look like?
Wouldn't it just be the same?
Would it be the same? No. Because the derivative, if we had it be the same here, the derivative of this thing that is the same would be 0. So we took the derivative of this,
Yeah.
that would be this. Okay, what is this going to be here? What is the meaning of f prime of x being equal to 2? What does that mean? What is the meaning of first derivative? What is the meaning of slope? It goes back to the calculus roller coaster, beginning of the year. What are synonyms for first derivative?
Trying to remember.
Well, you look at the drawing. You were about to it. Look at the drawing. What does it say?
Oh.
Yeah, there it is. There it
So
is.
the tangent line.
Slope of the tangent line. So what is this going to be? What is this a what? This is a what?
Derivative.
Is a derivative, but is a slope of what?
The tangent line?
Of a tangent line. And what is the value of that slope? Slope of 2. So what is going to be this thing over here? It's going to be this. It's going to be this thing right here. Slope of 2. And we don't know, it says possible because we don't know exactly where it is, right? Could be up here, could be up here. We don't know.
Just as long as it's supposed to.
Yeah, okay, so over here, f of x could be 2x. It could be 2x minus 3, because if you take the first derivative of this, you get 2. Okay, next, this one right here, what is a possible, for the second one, what is your possible one here? You can make a number line right underneath it, figure it out, what is that going to be?
Oh, my glasses just came off.
Like that.
Oh, that's one.
No, because remember, this resulted in this, right? What, question mark, is going to result in this as a derivative of it? Okay, the number, you do your number line analysis, right? You got the number line, so you got f prime and f. What do you have here? What's your critical number? 0. What is to the left of this?
It's 4.
Negative. So this, right? What is it to the right of it?
Positive.
This.
That's correct.
So what is this going to look like? Looks like that's going to be, it's going to be y equals x. What is going to be, what do you go, what's a function that which one taking the derivative of equals x? What is it going to be over here? The derivative of what? So we say if f prime of x is x, what is going to be f of x? What do you take the derivative of to get here? So what's going to, what you take the derivative of something to get x, so what's going to be, what do you take the derivative of to get x? If you're going to create a derivative and you get f prime of x equals x, what was this thing right here, or could it have been? This is x to what power?
0, 1.
X to 1. So what does this have to be? X to what power here?
0 or 2. No.
Which one does it have to be? It's one of those. Which one is it? It'll be 2. So it'll be x, it's going to be x squared, right? And what x squared is this going to have to be? If you take the first derivative, what do you have to have here?
2.
No.
2x.
What does this have to be to take the derivative of this to get you this? How about 1/2? take the derivative, cancel
Oh,
that.
I didn't know you were asking.
I can't, it's so hard for me to go from the derivative to what it's supposed to be.
Well, what it
I
is,
can find the derivative.
there's a power rule for that. Okay, there's a rule for it, but it's one that I hope this point in your, okay, this point, you should be beginning to be able to see that, okay?
I told myself it was a parabola, but then I thought it wasn't because I couldn't figure out what.
Yeah, here, there's another clue about being a parabola too, is that if you have a line like this, that is not a horizontal line, the the original function is going to be a parabola.
And when I did the number line in my head, I was like, that's a parabola, but I couldn't figure out like
Yeah,
what
that's how it
was.
does.
What made
And
it
if
a
you look at the
parabola.
beginning, when we got to this note card, the very last line, or if you get to the note card 34, the very last line talks about the degree of the function. You go to that note card 34.
The degree of an polynomial f prime of x function decreases by 1.
Yeah, the degree decreases by 1. So what happens is you have the original, your degree decreased by 1. So let's go ahead and look at these last two quickly, about out of class time. Okay, this one right here, this is a derivative. What does the original look like? Well, again,
The number line.
you can draw a number line. And do you have any critical numbers? Yes. But what's going to happen to each side here? Negative, negative. So you're decreasing. But see, you're decreasing here
That's-
faster because it's more negative. And so you're decreasing, it's going to go something like this. And then over here, you're decreasing still, but you're decreasing so the thing's going to look like this. So basically it's going to look like this. Decreasing. Looks like it's 0 here, so that'd be like a horizontal asymptote, and then like this. Oops. Be something like this. See,
I got
decreasing
that
all the
one.
way. You got that one?
Yeah.
Okay, now the last one here, what is this one going to be?
Oh. Gosh. I have it on my paper. I don't know why I'm sketching so hard to see it when it's right in front of me.
So to me, you're going like this, and this is your derivative, and so you're going to have something that looks like this. And then what happens over here at 1? You're going to have something like this probably.
Whoa. That's pretty wild.
You're going to break. And did the slope change? Well, you're still increasing because the slope, that was negative. Actually, the slope never got that, so that's incorrect because the slope never got there. So I just winged it, I was wrong. Okay, the number line will tell you the truth. So we do the number line, our critical number here, we're going to have negative, so we'll be decreasing, right? So we're going to be decreasing. I don't know exactly what it looks like, but things will be decreasing. It looks like it's going to be similar to this one, really, except the corners won't be exactly the same, but it's going to look very similar to that first one. So that's it. We probably for real we'll start cold with optimization tomorrow.
Optimization. What's that?
Yes, note card 34. And that'll get us there.